volume can also be measured in centimeter cubed. If a cube measures 5 centimeters on all sides, what is its volume? So this is more of a math question than it is chemistry, but let's go for it. So this is my box, my awesome box. So once that measures to 5 centimeters cubed, or sorry, just 5 centimeters. So this is just a math formula. So volume is equal to length times width times height, or as I like to think of it as times side times side times side, because right, it's going to have the same thing. So all this in short is just saying volume is equal to S cubed. So let's plug that in to our formula, to this formula specifically. Volume is equal to 5 centimeter cubed. So now let's solve this. What's 5 times 5 times 5 3 times, because it's cubed? That's 25. 25 times 5, that's 25. Carry the 2. 5 times 2 is 10. 12, 125. So volume is equal to 125. Now we got to do this part. Centimeter cubed, which just stays as centimeter cubed. And that's the answer. Not a big deal, right? So let's go to number 8 now. So number 8, a cube is made of unknown substance, measures 3 centimeters on all sides, and weighs 5.541 grams. What is the density? All right. So same thing again. We're going to use the same formula. V is equal to S cubed. So we're going to plug in our 3 because that's what we want to figure out. It says on all sides. Boom. Cube that. So 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So that's centimeters cubed. So our volume is equal to 27 centimeters cubed. But now it weighs what is the density? Go back to this formula. Density equals mass over volume. So our mass is 5.541 grams over 27 centimeters cubed. And that equals 0.2052 grams over centimeter cubed. Not bad, right? That's a terrible 5, I'm sorry. Forgive me, guys. So yeah, 0.2052 grams over centimeters cubed. Now let's go to the next one. I'm going to erase all this. Let's go to number 9. Let me get my pen back. There we go. So an object, I'm going to move that out of the way. An object with a mass of 8 grams was placed in a graduated cylinder with an initial volume of 11 milliliters. After the object was placed inside the graduated cylinder, the final volume was 50 milliliters. What is the density of the object? Okay, so a lot going on, right? But I like to be visual. So we have 1 graduated cylinder, right? 2 graduated cylinders. So I'm just going to do this. So in the first one, it measures up to 11, right? The water or whatever liquid. And then when we dropped in our item, it raised up from 11 to 15 milliliters, right? So we're trying to find the density of this object. And believe it or not, this is not really hard. This is pretty simple. So first things first, let's get our volumes. We're going to solve for our volumes first. What was our final? 15 milliliters minus our initial 11 milliliters. That equals 4 milliliters. Got our volume. Boom. Now we got our mass, got our volume, and now we need to find what is the density. So density is equal to mass over volume. Let's just plug and chug. Mass is 8.0 grams over 4 milliliters equals, right off the bat, 4 times 2 equals 8, so that's a 2. And then obviously just grams over milliliters. This is our density. Not bad, right? The density of an object is 3 grams per milliliters, and its mass is 6.575 kilograms, period. What is the volume of this object in gallons? Okay, a lot of mouthful, but really they give us our values what we need. This is not too hard, so let's do it. So density is equal to mass over volume, but what we want is to find and solve for volume, so we're going to multiply both sides. Hope you can see that. Use pink. Boom. It's furious. That cancels out. Divide d to both sides. Now we have our formula. V equals m over d. So now let's plug and chug. Our volume will equal, what's our mass? Mass of 6.575 kilograms. And our volume, our density, not our volume, we're trying to solve that, 3.00 gallons per milliliter. I'm sorry, gallons, grams. So, big problem right now. See how we have kg, and this is a g? We got to convert that kg to g. So, with this being said, let me clean up this area. Kind of looks cool. Shouldn't have erased that. God, these erasers are not responsive. Okay, back to this. We're going to really quickly convert 6.575 kg. We'll do it over here. 6.575 kg to grams. So the easiest thing you got to do, because kilograms, remember, kilo is 1,000. 2, 3. How many zeros do we see? 3. So 1, 2, 3. So 6.575 kilograms is equal to 6.575 grams. Yes, it is that easy. So this changes, let's just take that decimal off, take off the K. Boom. Grams, that matches out. Now, once we saw that straight through, these would cancel out. We've explained in prior videos how that happens. So we would have 6,575 divided by 3. That would come out to 2,191.6 milliliters, because that's what's left over. Now, they want us to convert from what we started with to gallons. They want in gallons. They're really specific. Why? God knows. So let's just erase everything really quick. So we're going to start over here. Sorry, there's not a lot of space on this. 2,191.6 milliliters. This was our answer. So there is, okay, so when you have something like this, where we have to get to gallons, you know we're going to use 2 of these. However, there is a way around it. And the way around it is really to just memorize various types of conversion factors. So for example, I know that 1 milliliter to gallons, GAL, that's what we're trying to get to, is 3 zeros, 2, 6, 4, 1, 7, 2. I know it's long, but yeah. So this cancels out with the milliliters. So we do this number times that number, which equals 5.789 gallons. Just to save us some time. Not bad, right? I hope not.